Hello, I'm Alan J, and welcome to the GCSE Maths Tutor channel. In this, the fourth tutorial, we'll take a look at simplification by reduction for larger numbers. As certain numbers become larger, there comes a point when the squares of the numbers can't easily be recognised. We need a quick method to quickly break down any surd number into its base factors. The method is quite simple. All we do is divide the surd by prime numbers, starting with whichever seems appropriate. If the surd number is even, keep dividing by 2 until the number is odd. If the number ends in a 0 or 5, then divide by 5, and so on. Eventually, we're left with the highest prime number as a remainder. The surd number is the product of the remainder and all the prime numbers used in the division. Then it's a case of grouping pairs of like prime numbers and removing them from the surd by reduction. All will be clear when you study these three worked examples. Number 1. Simplify the square root of 23,100. We start by drawing a diagonal line down the page about 7 lines down, placing the surd number inside the line at the top, and start dividing by primes to the left of the line. So we'll start with 2 into 23,100. Okay, 2 into 2 goes once, 2 into 3 goes once, carry 1. 2 into 11 goes 5 times, carry 1. 2 into 10 goes 5 times, 2 into 0 goes 0. Next line. 2 into 11 goes 5 times, carry 1. 2 into 15 goes 7 times, carry 1. 2 into 15 goes 7 times again, carry 1. 2 into 10 goes 5 times. Now we're left with 5,775, so we'll divide by 5. So 5 into 5 goes 1. 5 into 7 goes 1, carry 2. 5 into 27 goes 5 times, carry 2. 5 into 25 goes 5 times. The number ends with a 5, so let's divide again by 5. 5 into 11 goes twice, carry 1. 5 into 15 goes 3 times. 5 into 5 goes 1, so we're left with 231. So let's try 3. 3 into 23 goes 7 times, remainder 2. 3 into 21 goes 7 times, so we're left with 77. So we'll divide by 11. 11 into 77 goes 7 times. Writing out the surd number in terms of its factors and grouping like pairs, we have the square root of 23,100 equals the square root of 2 times 2 in brackets times 5 times 5 in brackets times 3 times 11 times 7, which equals the square root of 2 times 2 in brackets times the square root of 5 times 5 in brackets times the square root of 3 times 11 times 7, which equals 2 times 5 times the square root of 231, which gives us our final answer, 10 times the square root of 231. Number 2. Simplify the square root of 88,935. The number ends with 5, so we'll start by dividing by 5. So 5 into 8 goes once, carry 3. 5 into 38 goes 7 times, carry 3. 5 into 39 goes 7 times, carry 4. 5 into 43 goes 8 times, carry 3. 5 into 35 goes 7 times. 3's into 17 go 5 times, carry 2. 3's into 27 go 9 times. 3's into 8 go twice, carry 2. 3's into 27 goes 9 times. We'll try the factor 7 next. 7s into 59 goes 8 times, carry 3. 7s into 32 goes 4 times, carry 4. 7s into 49 goes exactly 7 times. So we'll try 7 again. 7s into 8 goes once, carry 1. 7s into 14 goes twice. 7s into 7 goes once. Now 121 left. We'll try 11. 11s into 121 goes 11 times. Writing out the surd number in terms of its factors and grouping like pairs, we have the square root of 88,935 is equal to the square root of 3 times 5 times 7 times 7 in brackets times 11 times 11 in brackets, and this equals the square root of 7 times 7 in brackets times the square root of 11 times 11 in brackets times the square root of 3 times 5, which all equals 7 times 11 times root 15, which equals 77 root 15. That's our answer. Number 3. Simplify the square root of 10,140. So 5s into 10 goes twice. 5s into 1 goes 0. 5s into 14 goes twice. Carry 4. 5s into 40 goes 8 times. 2s into 2 goes once. 2s into 0 goes 0 times. 2s into 2 again goes once. 2s into 8 goes 4 times. 2s into 10 goes 5 times. 2s into 1 goes 0. 2s into 14 goes 7 times. Now we'll try 3. 3s into 5 goes once. Carry 2. 3s into 20 goes 6 times. Carry 2. 3s into 27 goes 9 times. Now we'll try 13. 13 into 16 goes once. Carry 3. 13 into 39 goes 3 times. Repeating the method from the first example, writing out the surd number in terms of its factors and grouping like pairs, we have the square root of 10,140 equals the square root of 5 times 2 times 2 in brackets times 3 times 13 times 13 in brackets, which equals the square root of 2 times 2 in brackets times the square root of 13 times 13 in brackets times the square root of 5 times 3. So this equals 2 times 13 times the square root of 15, which equals 26 root 15. Hopefully now surd reduction with larger numbers is demystified and the lesson has been of help to you. And if you enjoyed the offering, I'd really appreciate you giving the channel a like, favourite or a subscribe. Anyway, do look out for the next in the series. Lesson 5 is also about simplifying surds by reduction, but with more terms. And don't forget, any comments on the show, suggestions to make it better, or ideas for new videos are always welcome. Thank you all for watching.